Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we're going to continue our discussions of reversing malware. In the previous video, we gave you kind of an overview, and in this video, I want to go through some of those first steps. What are the easy things that you can do right away if you have a binary and you're not sure what it is? So, very first thing you can do with any file, if you just don't know what kind of a file it is, or you suspect that maybe the file extension doesn't match what it really is, you might recall that under Windows just stupidly looks at file extensions and that's it. And that's how it determines what a file is. And Linux is a lot smarter. So Linux has a database of different file signatures built into it. And so you can use the file command, which will access that database, in order to get some information about a file. So I have a couple of files here in this directory, and I'll pretend I don't know anything about them. And I can go ahead and run the file command on these unknown binaries. So I ran the file command on this particular binary, and it came up and it told me this is an ELF 64-bit LSB executable. So ELF stands for executable and linkable format. It doesn't stand for executable Linux file, which is a common thing that people think that's just not quite true. Actually, this is a format that's used beyond Linux and other Unix-based systems. So this happens to be a 64-bit file. It's dynamically linked. And here's the version of Linux it's built for, and here's its build ID. And it says not stripped. You might say, well, what does that mean? When you strip an executable, it will remove certain symbols from that executable, which makes it smaller, and it also makes it a little bit harder to run through a debugger. So this particular file has not been stripped. I can look at another file in this directory as well. And it is also a 64-bit Linux executable. What if I strip it? I'll go ahead and strip this one. And now if I rerun the file command, it says that it's been stripped. I might have some other files that I find on my system, such as this file. And it says it's an ELF 64-bit LSB relocatable. So this also is not stripped. And it is another ELF file. Now this one happens to be a module or a library file. Okay, so that's the file command. And that is sort of an easy first step. I'm not sure what this thing is. Let me run the file command on it. So what could be a good next step. The next thing I could ask is this a known bad file? In other words, is this a file that is known as a file in a couple of databases that we have out there? So let's have a look at that. So the first thing I want to do is I want to make a hash of my file. So which hash should I use? In forensics, a lot of people are still using MD5 hashes, which, as we know, are not the best. A SHA hash would be better. But I'm just going to go ahead and create an MD5 hash of one of these executables. And now I have my hash. So now I can take that value and I can attempt to look it up. So I want to go ahead and look up this hash. So the first thing I want to do is I'm going to grab it, copy it to my clipboard, and now I'm going to go to a website. Now there are a couple of places you can go, and we'll start with this one. So if you do a Google search for malware hash lookup, you will probably land on this site, Team CYMRU, and they will tell you a little bit more about how to use this service. There are a couple of ways you can access this service. One of them is to use Whois. You can also use DNS lookup, HTTP, HTTPS. And we'll go ahead and use Whois. And they show you how to do this. So I can run a Whois command with -h, and I give it my address, hash cymru.com, and then I give it my hash. And this will look up based on a MD5 or SHA-1 hash. And let's see what happens when I do just that. So if I go back to my command prompt, and I say, Whois, I notice that Whois is not installed, so I can fix that. The wonderful world of Linux. So I want to say Whois -h hash cymru.com, and then I will give it my hash value. Now it came back and it said, here's the hash you gave me. Here's the last time this was queried. And of course, this is using seconds since January 1st, 1970. And it says no data. So basically it's saying, don't know this file. Haven't seen it before. I could do something similar with my other file. And here, let me do something a little fancier. I'm going to do a whois -h hash cymru.com. I'm going to say $ parentheses MD5 sum on Xing's. Oops. Do that again. Who is hash cymru.com MD5 sum Xing reverse shell. And it says also no data. So what did I do here that was fancy? Instead of calculating my hash and then pasting it, I used this construct where I put a command inside of $ parenthesis. And what happens when you do this is it'll spawn a subshell, it'll run this command, and then the results are just pasted right in here into this command that I'm running. So that is one utility for checking to see if your file is a known file. Now, I didn't get any hits here, and honestly, that's not terribly surprising. And why is that? Most of these databases are full of Windows malware. Well, why is that? There's tons and tons of Windows malware. That's why. So that is why you're not as likely to find this when you're dealing with Linux as when you're dealing with Windows. But it's still worth a shot. So that is one database that you can use. There is another database that is kept by the National Institute of Standards and Technology, which is a U.S. government organization. So you can find that on their website. So the easiest way to find that is probably to do this. I would just go to my browser and I would look up NIST, and it's the NSRL, National Software Reference Library. And on this website, you will find a couple of things. You will find where you can download this library. And this library has MD5 hashes in it. And you can also find information on some sub-projects. You can find out a little bit more about this library. They talk about the RDS, a reference data set, and what's in it, how you can download it. You can just download the whole thing and put it on some DVDs or just store it somewhere. They also talk about some legacy tools that you can use, some Perl modules, etc. And then if you look at these sub-projects, you will find a couple of tools that you might be able to use in order to check and see if your hash is in this database. Again, if you are working with Windows, I would definitely recommend you download this database and you look at it, because it is much more pertinent to Windows machines than Linux boxes. But I wanted to at least introduce it here. Okay, so we've done a couple of basic things so far. We have run the file command. We have done a hash. We've checked against 1 or 2 databases. What else can we do? Well, the next simple thing that we can do without having to really get into it is that we could run the strings command. So what does the strings command do? The strings command just looks inside of a binary and it will print out things that could be strings. So if I run this on this program, I'm going to pipe it to less. You'll see a bunch of stuff that it's going to print out. So how is this useful? Well, I notice a library, another library. There's my libc. And I see a couple of other strings. These strings look like function calls. So I'm calling socket, fflush, exit, htons. This is used to translate network addresses, file open fork, put character listen, popen, get process ID, fgets, stir length, send, memset, stir, bind, read, dupe2, standard out, fclose, etc. So I can tell right away that this thing uses sockets. So this is a networking application. If I go a little further, I see things like start main for libc, gmon start. I see some strings here for different versions of libc. I see some file names, it looks like. And I see this string, and that's followed by password. So if I had to guess if there was a password stored internally inside this program, that might be a good guess for the password. Swordman with a 0 and a 4 substituted in the middle. Some error messages, it looks like. A Python command, bin bash. So it looks like this thing wants to create a shell. A couple of other strings in here. Bind shell password, root shell password. And now I see a bunch of functions that are being used. So when I see something like this, standard out, at glibc, blah, 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 set socket opt, at. These are references to library functions that are being called. In this case, from libc, htons, same thing. And now I see a bunch of other strings. And that's pretty much it. So without understanding any assembly or having to look at any assembly, I already have a pretty good idea what this thing does. At least what sort of functions is it calling. This is obviously a networking app. And there's being some sockets that are being used, and it looks like it might be trying to spawn a shell. So seems a lot like malware to me. What about the other one? Same story. I see all these socket functions. Paths to my temp directory. that same string. Looks like some error messages. And a few other things. So, yeah. Doesn't look good for our little executable here. Looks like it might be malicious in some way. Again, we haven't done anything fancy yet. We just looked at it with file. We did a hash, tried to look up the hash, unsuccessfully in this case. And we just used strings to look at this. So that is it for our first steps. If I wanted to delve a little bit deeper, I certainly could. But this is pretty much all I wanted to talk about in this video. Now, as a reminder, this video is one in a family of videos that we have here at Pen Tester Academy, your source for everything InfoSec. And I look forward to seeing you in this course or another course soon. See you then.